In this video, we will look at how to deal with elasticity of demand. Before we can do elasticity of demand, we need to look at relative rate of change. So the formula for relative rate of change is f prime of x over f of x, while the percent rate of change is 100 times f prime of x over f of x. As an example, suppose Nike stock is selling at $84.90. and GM is selling at $39.51. Suppose you hear that Nike stocks will increase by 2% in the year, and GM will increase by 1.5% in the year. Which is the better deal? Nike stocks is increasing by 2%, so the rate of change for Nike stocks is f prime of x is equal to 2%. Relative rate of change of Nike would therefore be is going to equal 2% over top of the 68.29, which is approximately equal to 0.029. That means the percent rate of change is about 2.9%. The GM stock is increasing at 1.5%. So the rate of change for the GM is f prime is 1.5%. The relative rate of change is going to equal 1.5 over top of the 39.51, which is approximately equal to 0.036. And that means the percent rate of change is 3.6%. This means that GM would be the better deal since the relative rate of change is greater for GM over Nike. Example number 2. Suppose the price of quantity Q is given by P of Q is equal to 500 minus 6Q. Find the relative rate of change when the quantity of 75 items is sold. So first we need to find P prime of Q. P prime of Q would be minus 6. So the relative rate of change is equal to P prime of Q over P of Q. So that will be negative 6 over top of 500 minus 6Q, which is 6 over 6Q minus 500 if you just switch it around. When Q is 75, the relative rate of change would be P prime of 75 over P of 75. Well, that will be 6 over 6 times 75 minus 500, which is equal to approximately equal to negative 0.12. Now let's talk about elasticity of demand. Example number 3. Suppose a fast food restaurant has a price demand equation of Q plus 400P is equal to 3,000. Currently, the price of a hamburger is $3. If the price is increased by 10%, will the revenue increase or decrease? So Q is equal to 3,000 minus 400P is the price demand equation solved for Q, the number of hamburgers sold. How to figure out if the revenue will increase or decrease if the price is increased by 10%. It is currently at $4. An increase of 10% means the new price is 4 plus 4 times is $4.40. However, will people want to buy a hamburger at that higher price? You need to know how the demand will change as the price increases. Some items, an increase in price doesn't change the demand. This is because they are necessary and there are no acceptable substitutes. Examples are utilities, prescription drugs, and tobacco products. So the demand doesn't change even if the price increases or decreases. Items where the demand doesn't change if the price changes have inelastic demand. On the other hand, if the demand for an item decreases as the price increases, the item has elastic demand. Examples of elastic demand are things such as name brand food items, cell phones, candy, automobiles, and other items where an acceptable substitute are available. To find the elasticity of demand, you want to look at the relative rate of change divided by the relative rate of change in price. So the elasticity of demand is E of P is equal to the absolute value of the relative rate of change in demand over the relative rate of change of price. Well, the relative rate of change of demand is F prime of P over F of P, which we just did before. And the relative rate of change of price is F prime of P divided by P. That gives me F prime of P over F of P over 1 over P, because the derivative of P is just 1. Simplifying this, you get the absolute value of P times F prime of P over F of P. The reason for the absolute value is because the demand is a decreasing function of the price. In other words, if the price goes up, the demand goes down. This makes the derivative demand negative. To make the elasticity positive, no good reason, but you want it positive, one needs to take the absolute value of the ratio to make it positive. One could also multiply the ratio by -1 to make the ratio positive. So another way to see the formula for the elasticity of demand is like this. E of P is equal to negative P over F prime of P times F prime of P over F of P. This illustration shows what happens to the revenue as the price increases. As the price increases and the function's increasing, the revenue function's increasing, then as the price increases, the revenue will increase. The elasticity of demand, E prime of P, is less than 1, and increasing revenue, R prime, is greater than 0. On the other hand, if you're decreasing revenue, so R prime is less than 0, then as the price increases, the revenue decreases, and your elasticity of demand is greater than 1. This shows the relationship between demand, elasticity, and revenue. To summarize, if demand is not sensitive to price, then as price increases, revenue will increase. This is inelasticity, and 0 is less than E of P is less than 1. If demand is sensitive to price, then as price increases, revenue will decrease. This is elastic demand, and E of P will be greater than 1. So now, if the percentage increase in price produces the percentage increase in demand, then this is called unit elasticity, and E of P is equal to 1. So now back to the question about the fast food restaurant. Suppose a fast food restaurant has a price demand equation of Q plus 400P is equal to 3,000. Currently, the price of a hamburger is $4. If the price is increased by 10%, will the price increase or decrease? So, F of P is equal to Q. is equal to 3,000 minus 400p. Is the price demand equation solved for Q? And this is the number of hamburgers sold. F prime of P will equal minus 400. The elasticity of demand, E of P, is going to equal the absolute value of P times F prime of P all over F of P. So that's going to equal the absolute value of P times negative 400 all over 3,000 minus 400p. Well, this is just equal to the absolute value of negative 400p over 3,000 minus 400p. Now, look at this for a hamburger that costs $4. So E of P, E of 4 is what we want. So that will be the absolute value of negative 4,000 times 4 over 3,000 minus 400 times 4. That's equal to 1.23. This is elastic demand, and raising, because it's greater than 1, and raising the price will decrease the revenue. You need to decide if that increase is really what you want to do. Sometimes cost increase can mean that you need to increase price, but there may be a decrease in revenue if you do.